Goedemorgen allemaal. Heel trots om Dr. Philip de Rijk voor te stellen. Hij gaat ons een stukje bijbrengen over koekjes. Good morning everybody, Dr. Philip de Rijk. He travels the world. He informs us developers about security. I know Philip from some lessons that I had from him, and he is a very good expert at the topic. So thank you, Philip, for coming.
All right, thank you for the introduction. Just for showing up, awesome. We'll see if you keep it up after the talk as well. All right, good morning, everyone. I'm here to talk about cookies, and I chose a very dramatic title for my presentation. We hate cookies, and the title is kind of based on some frustrations that people have with cookies, some problems you may have run into, and some things you want to take into account. Just to set the record straight, we don't really hate cookies. We kind of love cookies. Cookies work really well for things like session management, keeping track of users, and we definitely rely on cookies on virtually everything we do on the web. Even modern deployments with OAuth and OpenID Connect, behind the scenes, there are cookies. So they are fundamental building blocks of web applications. They're absolutely crucial. The hate part is just about getting things right, and that's exactly what I'm going to talk about here. So cookies are not only good parts, cookies can also be attacked. So attackers can come after your cookies if they're misconfigured, which can result in all kinds of problems. Cookies themselves can also be the enabler of other attacks. I'll explain the kitty later. But in essence, cookies can enable other attacks, which is also a potential issue. Cookies can be abused for tracking. Cookies are a mess when it comes to tracking. They allow people to follow you around on the internet, and we'll talk a bit about that later in the presentation as well. And finally, cookies can help you go crazy, basically. They can drive you mad, especially when things are not working. They will drive you insane, and it's sometimes very hard to understand what exactly is happening, why it's happening, and what you want to do with that. And the goal for this talk, this plenary session here, this keynote, is to make you a cookie superhero. And in essence, the idea is that you understand what cookies, how they work, what you can do to configure them, and also when things go wrong, that you understand what's happening under the hood and why things might be getting into trouble. All right. I'm Philip de Rijk, and I heavily rely on ChatGPT to generate slide images, in case you haven't noticed. Don't worry, the rest is going to be a bit more substantial, so no worries there. I'm actually from Belgium, so this is kind of nice to come here by train for once instead of traveling to a different country. And I'm a security expert. I did a PhD in web security at KU Leuven a long time ago already. And right now, or since a whole bunch of years, I run my own company called Pragmatic Web Security. And the name is very deliberately chosen. Pragmatic, as in I help developers understand security, and then I work with them to find practical solutions for their requirements. Because it's not always about the best and brightest solution out there. It's about what works for you, what you can make work, and how you do that. And I do that through training, conference talks, conference workshops, in-house training, online courses, and also very specialized consulting. All right. I'm a Google developer expert, which doesn't mean I work for Google. It's basically a recognition program from Google for people contributing to the community with talks and articles and all of that stuff. So that's a very big honor to be part of that program. And I also organize SecOpDev in Leuven. It's a week-long course on application security, where we bring in speakers from all over the world to talk about application security. So if you're bitten by security, definitely check out SecOpDev. It runs in 3 weeks, so it's getting close. A lot of work organizing that, but it's highly relevant if you're into the security world. All right. If you want to grab a copy of the slides, you can scan the code, or you can look them up later. I'm really easy to find online. The slide deck is on my website. You can grab a copy. I promise there's more than just ChatGPT images. I have some actual content slides as well that you might want to use later on to refer back to the contents that we talked about. All right. Not a ChatGPT image. So that's one promise fulfilled. Let's talk about cookies. And I want to start with part one is the cookies that we bake ourselves, the cookies that we set, we configure for our applications that we control. Cookies where we can configure certain properties and make certain things happen or not happen in practice. And I'm going to start slow. I'm going to start by explaining the interaction pattern between a browser and a server with cookies, and then we're going to build on top of that throughout the presentation to show you good and bad interactions and how things go in practice. So what we have on the left is your browser. What we have on the right is a server serving an application. Restaurate.com is my training app about restaurant reviews. But just imagine it's a Drupal application for restaurant reviews, and off you go. I'm just making stuff up on the fly, but you kind of get the idea. The browser has a cookie jar. Cookie jars, I swear I'm not making this up. The browser has a concept called a cookie jar where it stores cookies inside. And essentially what's going to happen is when you visit a web application, a request goes out, a response comes back in, and in that response, the server can set a response header set cookie. And set cookie is going to create a cookie in the browser. In this case, with the name says something, with a random value, it's a session ID, and the browser is going to store that in the cookie jar. And in essence, you can see an entry in the cookie jar for restaurate.com with this cookie. Cookies are associated with domains. So whenever a request goes out to that domain in the future, the browser will see that going out, stop the request right, where's my highlighter, right there, look in the cookie jar, find the cookie for restaurate.com and attach the cookie to the request right here. That's essentially how cookies work. Request header is the cookie header, not a set cookie, but cookie with the key and the value. This is how cookies have worked since forever, basically. And based on the bald people in the audience, some of you definitely remember the day that cookies started working like this. That was before my time. I remember some of that stuff, but not all of it. But that's essentially how cookies work, all right? Cookies from the 90s. Cookies today work a little bit differently, as in this header here changes quite a bit. Today, you should set the header as follows, not just key value, but you have to add a whole bunch of a whole bunch of things to it to make it work the way you want it to work. And I'm going to talk about all of these in this presentation. Just a quick check. Who here knows what all of these things mean? A few people. Wow, that's impressive. I'm going to quiz you. No, I'm just messing with you. But there's a lot of things to know about these, and I'm going to walk through all of them. Don't worry. So how does that impact our interaction pattern? Well, the interaction pattern stays the same. It's just that step 2, instead of this set cookie key value, becomes set cookie, blah, blah, a whole bunch of things there. And the cookie header, well, the browser actually stores these in the cookie jar, these properties, the secure, HTTP only, and so on. And then the cookie header also has the modified name of the cookie, because we changed that name in practice as well. All right, good. Let's start at the beginning. The first two are really easy, really straightforward. So let me breeze through them, and then we'll see where we end up. The first one is a secure attribute. Secure attribute has been around for a long time. Actually, let's quiz you. Who here can tell me what a secure attribute does? Absolutely. Only reserving the cookie for HTTPS connections only. So it's basically about not sending the cookie over an insecure channel. Beautiful ChatGPT image. An insecure channel. So basically, whenever you have a HTTPS connection right here, the cookie will be set and will be sent over HTTPS as well. If the request goes out over HTTP, if step 3 is an insecure request, then there's no cookie. That's what that means. So basically, it's a way, it's actually an older thing from when websites were mixed HTTP and HTTPS. You could tell your cookie or tell the browser, this cookie is only for the secure part. Don't leak it on the insecure network where somebody can sniff it, and so on and so on. Very simple, very straightforward in practice. All right, what's the impact of adding that secure attribute to your cookies? 0, because you should be running your websites over HTTPS. If you're running your websites over HTTP, you have permission to leave right now and go fix that, because you should not be doing that. I'm fairly certain it probably doesn't work with Drupal, but I haven't checked, to be honest. If you're running your website over HTTPS, adding this to your cookie is a no-brainer. It doesn't do anything except it covers off some weird attack scenarios that may occur in practice. So this is on by default as well for session cookies on virtually all applications, including Drupal. Good. 1. See, that was easy. What does HTTP only do? Go on, the people that said, I know everything what's on the slide here. Awesome. You're not just a photographer, you're actually a developer or somebody who knows what they're doing. Yes, absolutely. HTTP only is about preventing JavaScript-based access to the cookie. I have an image for that. It's basically HTTP only, as in network traffic only, HTTP and HTTPS, but it's an HTTP request over the channel. That's what HTTP only flag does. Impact of this should also be nothing, basically, because today we typically don't write applications that need to read cookies from JavaScript. That's not a very nice pattern of building applications, especially session cookies, which are random junk. Nobody needs to read that from JavaScript. So cookies are typically, especially session cookies, are marked as HTTP only, and that covers off that base. In case something goes wrong with JavaScript, at least they can't read cookies. They can mess up your entire application, but they can't read cookies. Minor impact, very useful to set it anyway, and since it doesn't cause you any harmful side effects, then there's no issue. All right. If you're thinking like, oh yes, this is a very nice introductory talk for Saturday morning, that part is over. It's going to get a little bit more complicated as we dig deeper and deeper into the next pieces of content. All right. What about the host prefix, right? We're talking about this part now, which is part of the cookie name. What does that do? Crickets. Is anybody using the host prefix? No. All right. Finally, the interesting stuff is coming. Why do we have the host prefix? Well, in general, we have cookie prefixes because browsers are kind of weird. And browsers are weird, I mean that browsers, back when cookies were introduced, they were very underspecified, as in the idea was like the functional part of cookies, like you set a cookie, you send a cookie, and that part was kind of well defined and everybody understood what it meant and implemented that in the same way. But it's like the corner cases that weren't really defined and browser vendors just kind of did something. And you had all these different implementations and you had all these weird corner cases that were possible but didn't really make sense. For example, just one simple example. It's possible to set a cookie for a secure connection over an insecure connection. Here's what that interaction pattern would look like. So we have the browser and we have an insecure connection, right? No HTTPS, we send a request, we get a response, and the response says like, here's the set cookie header. And the set cookie header basically says, I'm in front of the picture, but says like, this cookie is for secure connections. And the browser is like, okay, fine, I'll get that. And the next time you make that request over a secure connection, that cookie is going to be there. And that doesn't make sense, right? Because reserving a cookie for encrypted traffic only and then accepting it over a wide open channel, that's kind of weird. And that's one of the consequences here. So why is this a problem? Because in theory, this is less and less common, but in principle, a network attacker, somebody on the Wi-Fi, intercepting your network traffic can manipulate that network traffic. And that means if you have HTTP traffic on top, the attacker can manipulate that, can give you a fraudulent cookie in the response, and then tell your browser, just use this for secure connections. And in practice, the attacker, if you have a session cookie for your Drupal application, the user, your victim has that, the attacker can override that session cookie with a different value. And I know this is kind of a funky attack scenario, but it's possible because browsers, at least in the past, accepted this type of cookie. And that allows for attacks like session fixation, where the attacker can override existing cookies, tricking the user into continuing in this session of the attacker, which can cause all kinds of problems as on its own, and so on, and so on. And that is definitely a very, very weird scenario. All right, here's the request going out from the user, and that cookie here, the red one, is now the malicious cookie set by the attacker, not the legitimate application cookie. Like I said, browsers are somewhat weird. This is something that somebody came up with after a while. It's like, oh crap, why are we doing that? That makes no sense. And that's one of the things for adding prefixes to cookie names, because with a prefix, you can enable strict browser handling for cookies. And one of the prefixes that you can use is the __ secure dash, which is complicated because of the need to avoid collisions with other cookie names and so on. So __ secure dash, if you add that to the name of the cookie, right here, you're basically telling the browser, I want you to be logical about cookies. Let's behave like a sane piece of software and accept cookies over secure connections only. So the secure prefix requires you to have the secure flag set on cookies, and it only accepts the cookie over HTTPS, which basically means even if the attacker is on the network, and even if they send you a set cookie header over HTTP, the browser, if the cookie starts with __ secure dash, the browser is like, I don't want it. And that is how you can avoid somebody from overwriting your legitimate cookies, because the browser will simply refuse to accept that. Of course, the big assumption we make is that we can trust HTTPS and the attacker can't break HTTPS. That's a story for maybe a different time. We're not going to talk about that. In general, you can make that assumption today. That is a fair assumption. All right, so that's a secure prefix. There's a second prefix, the host prefix. What is that really about? And the host prefix is about a variation on this attack where the attacker is launching the same kind of attack from a subdomain. So imagine that we have a subdomain, old.restrowave.com, that we don't really use anymore, and all of a sudden the attacker starts controlling that subdomain. The attacker can host content there. And the attacker can send you, the victim, a link like, oh, visit this website. And you visit that, and the attacker can now send you a response. And in that response, the attacker is going to include a set cookie header. Set cookie header, this is HTTPS, by the way, so that's all good. Good job from the attacker. HTTPS, secure cookie, and the attacker adds the domain attribute. And the domain says, this cookie is valid for all subdomains of restrogate.com. Which is like, that's weird. So what we have now is we have our legitimate cookie, the green one for restrogate.com. That's what we had from the beginning. And now we also have a star.restrogate.com cookie, which is the attacker's cookie, which is also stored in the browser. What's going to happen when a user visits a legitimate application on restrogate.com or app.rest or whatever subdomain? The browser is going to send both cookies. That's what browsers do. Browsers don't really reason about this. Browsers just like, oh, okay, here's a request to restrogate.com. I have a cookie for restrogate.com, one for star.restrogate.com. Yeah, that's good enough for me. And off goes the request. So what's going to happen on the application side? I don't know. It depends. It depends on how the server is implemented. Some applications flip out because there's two cookies with the same name. Some applications or application servers just use the first one they find, or some use the second one they find. It's very unpredictable. This is like a quirky, undefined scenario that shouldn't really happen in practice, but is possible because of the attacker controlling that subdomain. And I can see you thinking like, dude, who the hell gives an attacker control of a subdomain? I mean, don't do that. Well, yes, I can see it on your face. It's like, well, this happens in practice because of subdomain takeover attacks. Because our DNS configs are all CNAMEs these days, pointing to like cloud properties or hosted servers or this or that. And what happens is when you have this old.restrogate.com CNAME and you forget about it, and it just points to an IP address that you don't use anymore, and blah, blah, blah. And your life goes on. And after a few months, somebody starts hosting something on that IP address, and they find, oh, look at that, old.restrogate.com points to this IP address that I now control. And the attacker can host anything they want there, and they can launch this attack. That's how these things happen. And don't think you're too good for dangling CNAME pointers, because it happens in practice. I had that problem with my website, and I don't even run applications. So I'm not even sure how it happened, but somebody reached out to me like, hey, man, I can now host something under, I forgot what it was, blah, blah, their pragmaticwebsecurity.com. And I was like, what? And I went to check, and I still had a CNAME to something I didn't use anymore. And all of a sudden, it was a Netlify thingy, and all of a sudden, somebody could host something there. So I'm thankful that they reported that. And I fixed that issue. But this is actually a very, very big problem, especially in large organizations. I challenge you to review your DNS configurations. You'll find CNAME records that you don't use anymore that still exist, pointing to something. You already regret coming here? All right, so the details of the attack are a bit nasty. Maybe a bit hard to understand, but you don't need to worry about the attack details. What you need to worry about, or what is really important, is the fix. And the fix is actually fairly straightforward. The fix is adding the __ host dash prefix to your cookie name. Because __ host dash, trust me, this is not fun to say, but the prefix, the host prefix, enables everything that the secure prefix did, plus it ensures that the cookie can only ever be sent back to the host that set it. So if you set this from old.restrogate.com with that name, the browser will only send it back to old.restrogate.com, never to other domains or the parent domain or anything else. So basically, it neutralizes the domain attribute, and it prevents the attacker from abusing that in case something goes wrong. All right. By the way, you can configure these prefixes in Drupal as well. I checked. What's the impact of these? The secure prefix, impact 0. Why? You're running your application over HTTPS anyway. You're already setting the secure attribute, so adding the secure prefix doesn't do anything either, except it gives you added security without any impact. This is literally an update of like 2 minutes. If you find the right setting, done, off you go. The host prefix shouldn't have a big impact either. In general, today, cookies are not really shared among subdomains anymore. We have things like single sign-on and OpenID Connect, and we don't really need to share cookies among subdomains. So if you don't do that, if your cookie is just for your application on your domain only, adding the host prefix will also have little to no impact. If you are relying on shared cookies between subdomains, then things may get a bit messy. Either evaluate that pattern or just use a secure prefix instead. All right, but this gives you the option to enhance the security of your cookies and get rid of these quirky, weird scenarios that shouldn't really be happening in practice. All good? Good. What does same site do? Yeah, awesome. Thank you for that contribution. It's like, what does same site do? Yeah. All right. Yes. Your explanation embodies the "we hate cookies" part. All right. Well chosen title. Look at that. It has something to do with cross-site. Yes, same-site, cross-site. It has something to do with an attack called cross-site request forgery, or CSRF in short, CSRF, CSRF. I'm going to be saying CSRF instead of cross-site request forgery, just because it makes my life a lot easier. The common denominator here is site. What is a site? It's Saturday morning. I have to keep you awake. Come on. What is a site? The domain. Close. Maybe. It depends. That's always my default answer. It depends. And then there's like a whole explanation. Yeah, I can't explain this except by defining the site. So let me do that. That's going to be easier than just trying to freewheel something. The site is basically defined as, in this case, retrograde.com. And the site is the ETLD +1. This is going to get really technical, so bear with me. ETLD, the extended TLD, the .be, the .com, the .co.uk, the whatever, that is this part. And then +1, one level up, retrograde.com. That is the site of this URL. So the domain, yes, if you're running things on HTTPS retrograde.com, then it's the domain. But if you're running things on www.retrograde.com, then it's going to be the retrograde.com part. That is the site. All right. What does that mean for same-site and cross-site definitions? Well, if you have a bunch of URLs, well, let's walk through them together. If you have a bunch of URLs, the first one, login.retrograde.com. The site is retrograde.com. The site here is retrograde.com. Same site. All right. What about api.retrograde.com? Same site. All retrograde.com. What about myretrograde.com? Well, the ETLD is the same, but the host part, the +1 part, is different. MyRetrograde.com is not retrograde.com. That is cross-site. And then funny cat pictures, cross-site. No explanation needed there. All right. That's not too complicated, right? No, we can manage that, even on a Saturday morning. What about these sites? Are these same site or cross-site? Wrong. That would be way too easy. But just a tip for the future, whenever I ask something about this, it's not the logical answer. It's always going to be the non-logical answer. I'm just messing with you. Your gut feeling and everything I taught you would assume that this was same site, because I did not talk about the full details yet. Let's dig a little bit deeper. Why are these cross-site? Well, the TLD here, the ETLD, is not .io, but in this particular case, it's github.io. Because somebody at GitHub actually went to a specific list and registered github.io as an TLD, top-level domain, which means that everything on +1 becomes, this is the TLD, and that's the +1 part. So that means that bruce.github.io and batman.github.io are two cross-site resources. Why would someone do that? Like, what's the point here? Well, the idea is these are user-controlled resources, right? You can probably go to a GitHub repo and deploy that under GitHub Pages. This is GitHub Pages, so you can deploy that under bruce.github.io if nobody else did that. And then you control that. Imagine that people would do that, and all of these would be same site. That would have some consequences, because now we're pooling these things together, because same site basically means these resources loosely belong together. They're not the same, but they belong together, like properties of one company or something like that. And that would not make sense if we give control to God knows who to one of these resources. And that's why somebody at GitHub said, like, yeah, you know what? We want stronger security boundaries, so we're going to register github.io as an ETLD, which implies that everything on the +1 level, like Bruce and Batman, becomes the site, and these are all cross-site. You can check this list. It's called the public suffix list, and it's literally a text file, a TXT file, with a whole bunch of these ETLDs in there. And browsers have this hard-coded in their source, so whenever you install a browser, it has this list. It knows how to evaluate same-siteness and cross-siteness. All right? You could apply yourself. Everybody can ask to be put on the list for a specific domain or whatever you're doing. In general, that's a really advanced use case. I don't really recommend doing that unless you really know what you're doing and you're dealing with very user-controlled content that's untrusted and so on. But that's a pretty advanced case that we don't have to go into. I just wanted to make sure you had the full context on same-siteness and cross-siteness. So how did we get into this hole? Well, we started talking about same-site cookies, and that's when we went off the deep end, talking about same-siteness and cross-siteness. So back to same-site cookies and cross-site request forgery. What is cross-site request forgery, CSRF? A CSRF attack is basically a scenario where the attacker, me, sends a request from your browser to restauraway.com to create a review. That's the attack scenario. So you visit my webpage and I create a review in your name and you don't even realize that that's happening. That's CSRF. Or you visit my webpage and I send a message on Facebook. I post something online on your Facebook timeline. Just like that. How does that work? That's where the funny cat comes into play. The setup point, as a user, as the victim, you guys, you're the victim here. You have an active session for restauraway.com. Right? Your cookie jar has a cookie. The cookie points to a session. You have secure, HTTP only, all the flags enabled, host prefix, good. And then, once the browser has the cookie, you visit funnycatpictures.com. Because who doesn't, right? Funnycatpictures.com, it's colored in red, is an indication this is an untrusted web. It looks very funny, but it's not really trustworthy. But you don't see that from the outside. All you see is funny cat pictures. So what you do is you send a request, and you get a response. And the response shows you funny cat pictures. Very logical, very straightforward, right? However, in the background, that page, it's now running in your browser, loaded in your browser. In the background, that page can load an iframe. And in that iframe, that page can send a request to restauraway.com. And what does the browser do? The browser sees that request leaving here and says, like, hold on, restauraway.com, I have a cookie. And it slaps the cookie on that request, because that's what browsers do. And then the backend sees that request coming in. The backend in this case is unaware that this can happen. They should have implemented defenses. They didn't. The backend sees a request coming in like, ooh, create a review. Awesome. Who is this? Reads the cookie, host __ host dash says something like, oh yeah, this is Philippe. Or no, I'm the attacker. This is, what's your name, sir? Val? All right. Trust me. Don't ever ask Scandinavian people about their name, because you're going to be screwed. I've had to ask people like 4 times, like, what was that again? I'm going to call you John. So Val, I can deal with that. Val. Awesome. So restauraway is going to process the cookie like, oh, it's Val. Flip, create a review, and off you go. And then you'll only notice this when you go back to the application after a while, like, hold on, I didn't write this, did I? How drunk was I yesterday? No, I don't think that was me. That's cross-site request forgery. All right? Seriously, if you don't remember what you did the night before, maybe it's time to lay off the drinking. Just a pro tip here. As a side note, health advice and cookie talk. So that's the attack scenario. Is everybody on board with the attack? This is not new information, by the way. This has been around since, I believe, 2008 that somebody first came up with this. Like a long time ago. Trust me. If you want to feel old, 2008 was 16 years ago. Yes, I know. Don't ever do that, those calculations. It's very depressing. What's the fix here? The fix is a same site attribute for cookies. Because same site, we now know the definition of a site. Same site basically tells the browser this cookie is only supposed to be used on same site requests. Do not include it on cross-site requests. And the attacker is still there, and Funny Cat Pictures is still online, and Funny Cat Pictures still sends that request to retrograde.com, and the browser sees it leaving. It's like, ooh, retrograde.com, I'm going to check my cookie jar. Hold on, same site, but this is cross-site, funnycatpictures.com and retrograde.com. I'm not going to send the cookie. And retrograde.com will still see the request. It's like, who are you? Oh, there's no cookie. I don't know who you are. Go away. And the problem goes away. That is what same site really means in practice. That's what I did in my PhD as well. I built a browser extension that actually does this in practice. Today, Chrome decided, screw CServe, let's fix it once and for all, and Chrome handles all cookies as same site. So even if you don't set a flag, you should still set a flag because not everybody uses Chrome and so on and so on. But if you, yes, that's not a joke, not everybody uses Chrome. But if you do not set a flag, Chrome will still treat it as same site. This was a big item a couple of years ago when they made that change because a lot of stuff broke if you relied on same site or cross-site behavior. All right? That's what the same site flag does. You should still set a flag because it's a good practice. It helps, it applies to other browsers as well. And you can actually configure the value of same site to specific behavior. And there's 3 options. Option number 1 is the default, lax. Lax sounds horrible security-wise, but it really isn't. Lax means cookie will be stripped or not present on all cross-site requests except for a top-level navigational GET request, which translates to if somebody clicks on a link and it navigates their browser to your site, that's going to be a cross-site navigation because you're coming from awesomewebsites.com and you're going to retrograde.com. That's a cross-site request, but it's a top-level navigation. So the browser, if you set it to lax, the browser is like, fine, I'll send cookies because CServe is not really possible on that level or shouldn't be possible on that level. And it allows you to resume your session from the first request the user sends to your website. That's lax. That's the default. You can set it to strict. That's easy. Strict is no cross-site requests with cookies. Done. Even top-level navigations. No, nothing there. And then there's none. And none is there because Chrome started doing this by default. Right? Chrome said, well, all cookies are same-site cookies now, unless you turn this off explicitly, unless you have an application that heavily relies on the cookie being present on cross-site requests, like an OpenID Connect identity provider. Those are services that have to turn same-site off, which in turn means that you become responsible to stop CServe. If you turn same-site off, same-site is a CServe defense, it's good. But if you turn it off, you have to make sure that you are not susceptible to cross-site request forgery. There are application-level defenses that help you cover that attack vector. All right. If you want to know more about cross-site request forgery, I have like a full hour talk on that topic. You can find it online if you're not sick of me by now or my slides. But if you really want to know more, I recommend you look at that talk. It's from earlier this year, and it dives into a lot of detail on cross-site request forgery. What's the impact of the attribute here? Well, in general, you should not really be impacted by this. If you didn't have to add same site equals none to your application and it still works, then I'm kind of guessing that you're not going to be impacted because all Chrome users will be treating your cookies as same site anyway. So the recommendation, set same site to lax explicitly. It's always good to have explicit configuration options. And then you should be good to go. If you have this service that needs cross-site access and so on, then you may have to set same site to none, but then you should be very aware of cross-site request forgery attacks and should make sure that you have proper defenses against those attacks. All right. That was a wild ride through all of these options. How are you doing? Are you good? Yeah. Now you know what these mean. Now you can say in confidence, like, yes, I know what these mean. Awesome. Any questions so far? They told me I have to throw something into the audience if you have a question. So if you want to catch the speaker, then I can throw it to you. No takers? I wouldn't trust my throwing skills either, so that's a good call. There might be some collateral damage if I try to do that. So we're not done yet, though. Don't worry. We only talked about our cookies. What about somebody else's cookies? I'm not talking about stealing cookies, but I'm talking about third-party cookies. The cookies that we don't really control, but may still need to be there, and so on and so on. There's a whole bunch of things going on with third-party cookies, especially with this announcement in 2020 about third-party cookie blocking. Who followed this story closely when it came out, like 4 years ago? Yes, 2020 was 4 years ago. Nobody? No, I know. It's Safari, like who cares? Well, one person. Apple user? Yeah, that's why you care. Everybody else is like, Safari, whatever. Don't tell John Willender I said that, by the way. Yeah. No, Safari is doing some great things, but they announced this in 2020, and some other browsers like Brave, a very privacy-oriented browser, is also doing that, and honestly, nobody really cares. And then Chrome said in 2020, like, yeah, we'll do it as well in a few years. And a few years became 3, 4. And Chrome now actually has this rolled out for the 1%. Chrome does this like test thingy. So 1% of users get a new feature and they just see if shit breaks or not. And if it does, then they cancel it. And otherwise they can progress and move towards enabling this. And the timeline for enabling full third-party cookie blocking on Chrome is end 2024, beginning 2025. So this is coming. This is real. This is now for everybody, not just Safari users. So what does that mean? What is third-party cookie blocking? Well, I can redefine third-party cookie blocking as in terms that we already understand. Third-party cookie blocking is that the browser will refuse to send cookies on the loading of cross-site resources. Cross-site, we know what that means. ETLD +1. Good. Look, I said something useful today. That's awesome. So we know what cross-site means. What are resources? Anything loaded from within the page. Anything. Images, obvious. Style sheets, fonts, whatever. Iframes, JavaScript requests to an API. Everything that comes from within the page that goes cross-site, no cookies. Done. All right. You may be wondering, like, why? Why? Tracking. Trackers abuse cookies to follow you across the web. You may have noticed this, especially when you're like building a house, like I am, and you're researching things, and you look for, I don't know, heat pumps, and all of a sudden, all the advertisements everywhere, it's about that thing. It's like, what the hell? That's basically tracking with cookies. How does that work on a very high level? Trust me, trackers are nasty in how they do that. I'm just going to give you like a very high level idea of how this may happen. We have our funny cat pictures again. This is not the attacker. It's just a website. And you already have a tracking cookie. So you visited a tracker before, facebook.com. Sorry, what? You visited a tracker before, and the tracker has set a cookie in your browser, the super ID something something, secure, HTTP only, same site none, because we actually want it on cross-site requests. And then you visit funnycatpictures.com. And funnycatpictures.com loads the tracker's thumbs up icon next to a cat picture, or just a hidden tracking pixel or whatever. And that's in the response. And guess what your browser does? Your browser's like, ooh, a pixel from supertracker.com. I'm going to load that image. And the request goes out, and this cookie is present on this request. And supertracker.com now knows exactly that user with ID CED955C4 is visiting funnycatpictures.com. If Supertracker is facebook.com, they know who you actually are. It's not just a random ID. They know, like, oh yeah, that's Philip, and here's all this info, and oh, Philip is looking at funny cat pictures. Interesting. Or God knows what you're looking at. That's why if you're looking for gifts for your wife, you want to use incognito mode, because then you have different cookies and so on and so on. But in essence, that's how tracking works across the web, and it's insane how much information they can collect. Because this is not just one website. This tracker, if they're on 50,000 websites and you visit some of them, they can collect all the information. And maybe one of these websites has user information about you, and they can collect like, oh, this is Philippe's email address, and oh, Philippe likes this, and here's some information from Philippe. And these things are worth a lot of money on the data brokering market, which is very shady. All right. That's why privacy-sensitive browsers like Safari and Brave said, like, screw third-party cookies. And third-party cookie blocking would basically prevent this cookie from being present, regardless of the config here. The cookie would simply not be there, and the tracker would not gain information. That's essentially the idea of third-party cookie blocking. The idea is good, but the collateral damage is insane. There's a lot of stuff that breaks because of this change in the browser, like a lot of stuff. All right? Simple things like cross-site iframe widgets. Like you have plenty of sites that deploy as an iframe widget and they rely on cookies. Thank you. They rely on cookies and they want to make sure that they can track a user for legitimate purposes, not for tracking, but for actually keeping track of what the user did before. Psh, no cookies. If you have cross-site API calls with cookies, like you call an API and you rely on the cookie for that API to be present, psh, cookie is gone. And if you run OAuth and OIDC flows, they run silent flows. If you rely on those silent flows, they rely on cookies being present, cookies are gone, and the flow breaks. I'm not sure if I'm going to make the 10 minutes. We'll see how that goes. That's third-party cookie blocking, and it's absolutely nasty. All right? So how can we overcome this? How can we fix this? Well, it depends on your perspective. If you're a tracker, if you're one of those shady people, then you see the upcoming thing of server-side tracking, which is actually even worse. But now it's an opt-in at least, so it doesn't automatically come from including the Facebook thumbs up button. It doesn't automatically enable tracking. But if you want to do the tracking, people are reverting to server-side tracking. So basically, if you're on a web shop and you click on products, whatever the product is, they're going to send that information to a tracking service to create like a massive data store about their users and track insights and so on and so on. So this is even more data that they can send because the web store actually has a lot of additional information on you. So that's actually not a very good development, to be honest. I just wanted to tell you that that's something going on. I'm not recommending this as a best practice. What you can do is you can take away the cross-site aspect, right? This is about cross-site resources. If we can make things same site, everything is first party, and the problem goes away. How can we do that? Well, if you control the applications you're doing and running the widgets, you can run a widget on widgets.restograde.com and include it in app.restograde.com, same site. So no third-party cookie blocking. And I kind of predict that a lot of service providers that now rely on cookies being present on cross-site requests will come up with deployment patterns where you create a CNAME that points to their records, and then you can use that CNAME to load the widget from their host and so on, and include that way. That's something that is probably going to change in the next half year. All right, so that's one option there. Other than that, the landscape is a bit unclear at the moment because Chrome is the first major browser to do that. The only browser with a massive market share. The other browsers have started doing that, but honestly, people really care when Chrome does something because it's not 90% of the market. So this is in active development. Google, of course, has a couple of ideas to solve this. Let me check. How much time do I have left? Just 7 minutes. Is that correct? All right. Then I can talk briefly about these things. So Google has a couple of things in the pipeline. One of them is chips. And chips is about a cookie attribute for partitioning cookie stores. So instead of one cookie jar, you would have one cookie jar per top-level domain. So restograde.com has a cookie jar, and funnycatpictures.com has a cookie jar. And within the cookie jar, you can have third-party cookies, which are freshly set and used within that partition state. And funnycatpictures.com can have their own partition state. And they can never overlap. So you can't track people across sites, but you can still rely on temporary sessions with third parties. That would be one option. Firefox does this kind of by default. Chrome has it as an opt-in mechanism. There's the Storage Access API, which is actually something that came from Safari from 2020, which involves user consent for sharing cookies among across sites. which is it's horrible. Basically, you get this pop-up. Remember the IE days of the pop-up? Like, do you want to allow this insecure stuff? It's like, well, I don't know. Yeah. Well, now it's for cookies. Like, do you want to allow, I don't know, this restaugrade.com to use cookies for this? I don't think this is going anywhere, to be honest. This might be good for business applications, which you configure through group policies, but actually relying on pop-ups with user consent on web-based applications, I don't see this. There's a concept called related website sets, which would allow you to define a set of websites, different sites that should be considered same site. So you could, for example, say, as the site administrator, the ones controlling the domains. So if we would be running restaugrade.com and awesomereviews.com, we could decide to merge these as a set of same site resources. But it's opt-in. Both have to opt into this. There's a limit of 5 that's being discussed, and you can't, of course, be part of multiple sets. So a tracker could not say like, oh yeah, I'm restaugrade.com and funnycat and this and this. That's not supposed to be the idea. This is Chrome specific. There's no intent for adoption across browsers, so this is something that may get there, but there's a lot of pushback in the community. So it's a bit of a weird. It would be a good option, but I don't think it's going anywhere. And then FetCM is under active development. It's about solving the OAuth and OIDC flow. Well, OIDC flows mostly, but there's a lot of things in motion there, so that's nothing concrete yet. But this is the landscape. I suspect a lot of things will change in the next 6 months. What can you do? Well, the impact of third-party cookie blocking is pretty massive. My advice is use your applications today in a browser like Safari or Brave and see what happens, because they already have third-party cookie blocking. If everything works perfectly fine in these browsers, then awesome, then you're probably good to go. If things break, if things don't work, if your widgets don't work, if integrations don't work, then you already know what's going on. And Chrome also has a whole bunch of resources on helping you audit your sites and identify problems and fix them and so on and so on. But this will have a massive impact when it gets turned on. Absolutely certain of that. All right. Key takeaways. Cookies need a lot of attention to configure them correctly. That's the we hate cookies part. You need to set these attributes. Some of them are on by default, others you have to enable yourself. You need to add the host prefix and so on and so on. It's a bit of work and it takes a bit of understanding to make that happen. Once you do, cookie security is really good. Cookies, if configured like we discussed in the presentation today, are secure. There's no security issues with that. Don't let anybody convince you that cookies are insecure. That's bullcrap. Send them my way if you need more context. Just tell them Philip said so, and that should count for something. And then finally, third-party cookie blocking is going to be massive impact-wise. My advice, audit your applications today. Well, not today. In this, let's say, second half of 2024, that should be on your list of at least analyzing the potential impact of this and making sure you're ready to tackle that. All right. I hope that with this, I fulfilled my promise to make you a cookie superhero. Maybe not as high as this guy, but somewhat in between maybe. And thank you for being here. I hope you enjoyed this, and I hope you enjoyed the rest of the conference. If you want to chat, I'll still be around until the first coffee break, and then I have to jet back home, well, train back home to have to my other responsibilities. But it was a pleasure being here, and I hope you enjoyed this. Thank you. We have 2 minutes for questions. Yes. Yes. Oh, yeah. Let's try this. Yeah, I don't know how it works. They just told me throw it, and that's
test one. Yeah, okay. So just a question: if you have like a quick example of something that's like what you showed that the site had a problem with, or that like a real world example of some of the things you said, like this company had this problem and they had these consequences.
Sure. Where do I start? To be honest, the security HTTP only are probably not going to be that relevant. Cross-site request forgery is definitely a real-world attack scenario. You can find plenty of examples. OkCupid is a dating app, relies on cookies. I just know that from my other slides. Relies on cookies. they had a cross-site request forgery problem in their APIs. Grafana had something in their APIs as well. If you hosted it on a subdomain, then you would be vulnerable to CSRF. And then the third-party cookie blocking problem definitely appears in a whole lot of places. OAuth and OIDC, a whole bunch of flows are broken because of it, without any path to recovery. Basically, it's just like, yeah, it doesn't work anymore. So yeah, if you look for the attacks I discussed, like cross-site request forgery, subdomain takeover, you'll find a whole bunch of resources pointing to specific examples.
Yeah, I don't know. I see the whole situation with third-party blockers as a big players game. With Google being able, after a threat from Apple, that they want to stop all tracking from Google advertising. And then after Google found their solution, how to overcome this, they came with the third-party blocking in Chrome, right? So it's kind of affects everyone, but it's Google who is the big player in the advertising market who decides this. So in ideal world, how would you see the regulation of all these things, the technical part?
Honestly, you're absolutely right about Google. That's why it took them 4 years to come up with a third-party cookie blocking, because they had to find a different way of tracking people first. Says the cynical me. I fully agree with that take. What's the ideal world? To be honest, I don't know. I live in the real world. No, I don't mean that in a negative way, but I work with developers on finding solutions for their problems. So I'm mostly focused on that's how things are and how we can make things work. To be honest, I don't really have that much time to think about ideal worlds and regulations. I leave that to smarter people than me. So we can have a philosophical discussion on that, but I don't have a concrete answer on what it should be. Sorry. Anybody else? I'll make him throw the box. Just make him throw it and say thank you, and that's going to be fun as well. All right. Then thank you very much. The guy up front with the timing sheet is getting anxious, so I have to stop now, and we're done.